So let us start, Sanket.
Yes, sir, we can start.
So good morning, everyone. With myself, Niloy Rai, working in Scope as a lead product specialist, and with me, my colleague, Mr. Kiran Desai, who is the product specialist for the partial discharge products, is available. And Sanket is working as the overall admin or coordinator of this session. So, as a quick review, what we are going to talk today is the introduction to the byproducts of the partial discharge, how PD testings are done, PD testing methods, what are the different sensors available, and what are the recommended zone of or area of application, are the different frequency bands of those different sensors, some basic terminologies and the software features, what are desired for the PD testing, and at the end we will be talking about what are the different products which we are offering from our scope side. So as per IC 6270, partial discharge is known as the localized electrical discharge that only partially bridges the insulation between conductors and which can or cannot occur adjacent to a conductor. So it is a partial bridging of the gap or the bridging of the insulation, breakdown of the insulation, as the term itself is talking about partial discharge, so it is not the full discharge, and as it is a partial, it is not a continuous phenomenon. So it can happen, it can come and go, it may not happen or it will not happen rather for the 24/7. If it is happening 24/7, anytime it is going, it is not like the contact resistance or the winding resistance of a transformer where we can go anytime and we will be getting some values. So partial discharge, if it is happening, we have to catch the partial discharge at the right time. Now let us talk about the different types of partial discharge, whatever is, or the classifications of the different partial discharges. First one is the void. It is the air gaps or the any foreign object into the solid insulation. So it could be happening due to the manufacturing defect. Majorly it is the manufacturing defect, either some air or the other foreign matter, some metal pieces or the dust particles. If it is coming inside the insulation, it could be the porcelain insulation or it could be the other epoxy insulation, epoxy kind of insulation also. Any foreign object, whatever is remaining inside that insulation, that will be, that can create a void, and this void is going to create a potential difference or non equipotential surface of the insulation. As a result of the same, the breakdown may happen between the two walls of the void, two adjacent walls of the void, and as the discharge happens between those two walls, so internal material or the air bubble or can expand more. If it is a metal piece or other things, whenever there is a discharge, there will be some carbon deposition, and as a result of that, the insulation degradation is happening. And from this one we can understand it is a very highly destructive kind of a partial discharge. Then comes the floating potential. It is generally happening due to the improper contact. Generally, it happens into the joints or connections, terminations, etc. Those are very frequent, but not that much severe until and unless the joint is totally loose or something like that. Then comes the particle discharge. These are happening generally into the liquid or gaseous insulation. So it can happen inside the GIS or inside the transformer. And once again, it could be a very common type of a PPD, because particle discharge, because inside the transformer, or the inside the GIS, there could be the foreign objects getting generated. How the, let's say for the GIS, inside the GIS, if the breaker is operating at that time, some metal vapor will get generated due to the arcing happening in the breaker chamber. So that vapor of the thing will get cooled down, and there could be a regeneration of some metallic substance or some other component, or those metal things or some other components which are those remains floating in the floating condition, because those are not attached to a fixed surface or any specific position. Similarly, inside the transformer, let's say there are so many other foreign objects other than the oil, like we are having the spacers, we are having the insulation tapes, so many, there could be a rusting inside the transformer body, or in the inside the OLTC there could be some sludges are getting generated. So all these are foreign objects which are floating inside the oil. So any type of this foreign object, when it is coming to the high voltage zone, so there could be a discharge between this foreign object and the high voltage section or the live section of the electrical part, the electrical installation. So that type of a PD is classified as the particle discharge. And this is not at all a very severe condition, because as it is a floating condition, so it will get, the moment it is getting a charged or the discharge from the live contact, it will flow away or it will get destroyed. So it will come and go. It is not a permanent kind of a thing until unless the oil became too much dirty, or the SF6 became too much dirty. However, to get the solution for this one, filtration of the oil or filtration of the SF6 gas is the will solve the problem to a large extent. Then comes the surface discharge, another type of a very common type of a partial discharge. That surface discharge can happen to any high voltage location to the adjoining insulating body on the superficial level, like the post insulator, transformer bushings, CT bushings or PT bushings, those sort of surfaces. So there we can see the tracking kind of a, just like the roots of a tree, it will try to expand. So we have to look forward for those tracking, because initially these are not that much severe like the voids, but it can be a catastrophe, can lead to a catastrophic failure. So surface discharge is, you can say, we can say number 2 or number 3 category, where if the tracking is not, or the surface discharge is not getting not being taken care for at the right time, it will lead to a catastrophic failure. And last but not the least is the corona. Now there are fraternities, some people are talking about the corona should not be considered as a PD. Some people are talking corona should be considered as a PD. Some people, why they are talking corona should not be considered, because they are talking that corona is a physical phenomena of high voltage and it cannot be stopped. So corona should not be considered as a partial discharge. But the other fraternity, they are talking corona cannot be controlled, cannot be stopped, but it can be controlled, and it has to be controlled. Because if the corona level is increasing, then the surface discharge will start. And the surface discharge is a PD, and ultimately tracking will take place and it will go for a catastrophic failure. So corona should be considered as a type of PD, and it should be monitored, because, and also the PD diagnosis tools can also detect the corona. So it should be considered as a type of a partial discharge. However, it is the least severe condition till the time it is remaining as a simple corona. But the severity is increasing, then it will turn to the tracking, start tracking and surface discharge, then the catastrophic failure is cannot be averted. Now, what are the looking for the byproducts of a partial discharge? When there is any discharge is happening, it is just like a flashover kind of a thing, smaller level. So when we are talking about this, so first there will be some light, because corona, it will also give some light. When there is some flash, so there will be some light, heat, and there will be some chemical decomposition of the products or the surface or the components will be happening, some gaseous gas formation, some sort of a burning. So it is a chemical decomposition will be happening. So that can be, now light, sometimes it is visible, sometimes it is not. Like corona, in some specific cases it might be visible in the naked eye also, otherwise it is not visible. But if it is a flashover, it can be visible, the chattering or the spark we can see. Heat, yes, it is effective as a, we can see it as a hotspot. See, it means it, through the infrared camera or something like that, we can understand the hotspots which is getting created as a dissipation of heat into the PD spots. Chemical, through the gas analysis inside the GIS chamber or inside the from the transformer oil DGA, dissolved gas analysis, we can understand what type of chemical got generated and what could be the reason out of that. Those things can be done. Then comes acoustic, which it could be audible or it could be ultrasound also. Because let's say there is a spark, sometimes we can, if it is a, on that zone of nature, we can listen it, but on our bare ears. But it cannot, might not be audible. When it is not audible or it is outside our human ear listening capacity, it is termed as the ultrasound waves. And these ultrasound waves, on in a last word, no, not the most severe thing is that electromagnetic waves which are getting generated. And for the partial discharge measurement, these electromagnetic and those ultrasound acoustic signals are the most important zones which are getting measured. And based on that, what type of a PPD and how much it is severe or not, those are getting detected. So I want to ask you over one question. We want to ask as a poll, that are you doing the PD testing for your assets? The poll is live. You can answer. Some of the people has already answered, so you can answer that as a yes, no, or sometimes yes means you are doing is on it on regular basis. No, it is not done till date, or your philosophy is it is not required. Sometimes it is done once or few times you have done it, or it is used to do when doubted. You are doing it when some doubts you are it is coming to your mind. At that time you are doing the testing. So you can click on the poll section and you can give your answer on that one, yes, no, or sometimes. I will request all of you will participate into this poll. I will be coming to the other poll questions subsequent time. And for the time being, let us now proceed to the next one. Now, why PD testing? As I have asked, yes or no. So your question might be why I should do the PD testing. Because you, if there is any problem, we have to locate that problem, whether that problem is inside or on the surface of the insulation. If it is something going bad inside that is not visible from outside, or if something is visible already from the outside, it can be used as a very much predictive analysis tool. So what is going to happen down the line, 2 months, 6 months, 1 year, 2 year, or 5 years in the instrument, that can be done. It can work as an early alarm system. So you will understand it as a early alarm if something is going wrong, so you can detect it early, and early detection will lead to or prevent from the catastrophic failure. And for the PD testing, a lot of methods are available, and the most popular one is the online testing. So you really do not require any shutdown. So you did not have to worry that I need to take the shutdown when I'll get shut down in that fashion. So you can do it the testing online condition itself, and you can carry on your without discharge, without the shutdown. So no shutdown, no permission as such from the grid is required. What you will get, the magnitude or the discharge pulses, magnitude of the discharge pulses, so how much severe it is, how much pulse is getting repeated, pulse repetition rate. Means how many pulses are coming, whether it is how much repetitive or it is not repeating, once coming and it has gone, not any problem. So it has to be done not a single time, but over a period of time you have to do it, maybe a few hours of the day, or maybe on a repetitive few days, and it can be once again repeated after 1 month or after 15 days, different parts of that time day. It could be make one set of measurement in the morning, one set of measurement in the afternoon, one set of measurement in the evening, different load profile, different temperature profile you can get, because when PD will generate that, nobody has made any conclusion throughout the globe. People are talking that this, when the PD will at the highest voltage level or at the highest current level, or what is the scenario, nobody can. So you have to look forward for the different time. What is the discharge power? If PD is happening, how much it is severe, that can be understood from the discharge power of the partial discharge. And what type of a PD, based on which type of the PD we can understand that, okay, this type of a PD, so it is very severe, we have to take the shutdown and do the rectification. But if it is not that much severe, we can not to worry. When I'll do the filtration, it will work out for me, if it is a floating kind of a thing. Now PD testing, as for the normal human being, let's say if some person is getting detected with some sort of a tumor or something like that, doctors are not taking that person directly to the OT, because if there is a tumor, there are 10 different types of tests they are doing before doing the OT, before operating the person, because the thing has to be sure, we have to be sure, so it has to be correlated from different tests. So they are doing the ultrasound, they might be doing some other different tests, then correlating, yes, this is the location and this is the type of the or the nature of that tumor. Similarly, for partial discharge, there are the different correlation methods, like you refer it with the DGA results, because if you are getting the PD, what DGA is talking, if DGA is telling it is everything is fine, but you are getting some signal, then you have to really think whether the kit is giving the proper thing or how much severe it is. At this very moment it is getting detected fine, the kit is all might be also fine, but then as I have told, you have to repeat the test. So if the DGA results are not changing over a period of time, then there is a chance that the PD, whatever you are getting, that might be happening for that time, or it might not be a repetitive nature. So it is come and go kind of a thing. So you need not have to worry that much, because once I can get a loose motion as a person, so it is not a worrisome factor. But if I am not getting, or indigestion could be a 1 day problem of mine, but the moment indigestion is happening day in and day out, I have to be concerned. So same is the condition over here, because if something is going, some partial discharge activity is going inside the transformer or the GIS, in case of a transformer, we will get that reflection of the same into the DGA by means of various gases will get generated. Through the Duhal's triangle analysis and gas ratio analysis, we will be understanding, yes, there is the partial discharge. It will give the surety. The gas generation rate, how the gas is getting generated, whether the quantity of the gases is increasing or not, whether the insulation degradation is happening, that will give the gas from the gas generation rate and which type of a gases. By doing that analysis we can understand, yes. So everything will talk about the partial discharge. Similarly, if the insulation condition is going down before opening the transformer, let's say, or the GIS, you can go for a tan delta test, because if the insulation is going down, then resistive leakage current will increase. Resistive leakage current will increase means the capacitance resistive part of that insulation is going to get degraded. So the tan delta value is supposed to get changed. So tan delta will once again give you third indication towards the partial discharge or the insulation degradation. And if there is some hotspot like areas like joints or something like that, you can get through the thermography, you can get the yes, hotspot is also getting generated the transformer boosting, and I am also getting the PD. So it is getting correlated. In that fashion, we can understand the PD. That's the way we should do the PD testing. Now, what should be the steps we should follow? So first is the detection. I have to detect that something is going wrong. Then where it is going, or which type, what it is going on. Something is going wrong, but what is going wrong? That I need to identify, and then where it is going wrong. That some discharges are happening. So first detect it, then which type of discharge it is happening. Identification, where it is happening, that is the localization, and whether it is repeating in nature, that is nothing but the trending. So we have to consider these 4 steps into the partial discharge testing. Now PD test methods could be, PD can be tested with the online version or the offline version. Offline is not that much easy, as well as it is not popular, because not popular reason is it is not easy, because we require to take the shutdown. Then we should have a high voltage generator, which that generator should be PD free, or the PD free source we require, coupling capacitor we require. We have to ensure that no other partial discharge signals from the ambient is coming or entering into that room. So it is recommended to conduct the offline test under a Faraday's cage kind of a concept, or the inside that sort of a chamber. So these sort of a offline test might not be feasible or practically possible at the once that any instrument is there into the site, once it has erected. It can be possible at the majorly possible at the manufacturer's premises only. And second part is online monitoring, where we do not have to take any of the shutdowns or anything like that. However, on the online condition itself, we will be able to do the testing. In the online condition also, there are 2 bifurcation of kits. One is portable sort of a product. So you take that product, do the testing, online condition. If required, you can continuously keep that product on for few hours, even for few days, and then take away that kit to your thing. And once again, you take it for the next schedule. And other part is the continuous, where the sensors will be installed throughout the permanently into the test object, and the sensor monitoring will be going on 24/7. So 24/7, 365 days you will be getting the doing the monitoring. So that is the ideal or the final condition of the continuous monitoring, where we will not be missing any of the signals getting generated for due to the partial discharge. Now for the online PD testing, we are doing the, as I have told you earlier also, we are doing the wave emission technique. So this wave emission can be of two types, acoustic and electromagnetic. When it is acoustic, we can capture those acoustic signals through the airborne probe or through the contact probe. We will come to these different types of these probes or the sensors in the subsequent slides, along with the pictures and their frequency ranges. When it comes to the electromagnetic, there are three types of sensors: HF or the high frequency, VHF very high frequency, and ultra high frequency UHF. So HF is generally HFCT, so high frequency CT or coupling capacitors are the things which are categorized under the HF sensors. TEV or the transient earth voltage sensors are coming categorized under the very high frequency sensors. And there are different types of internal or external sensors and antennas are used under the UHF frequency band. Now let us see what are the different zones where we can use different types of sensors. So to understand that sensor application, let us talk about what are the different frequency bands which we are getting. So here in this scale, we are used a logarithmic scale starting from the 0 hertz at the left hand side, and we have gone up to 10 gigahertz as a scale. But now let us see what are the different sensors and in which frequency band they are operating. So first is the zone we want to talk, that what is the audible sound. Audible sound is the zone where we can listen. That is the zone or the thing known as the audible sound. Audible is from 20 hertz to 20 kilohertz is known as the audible zone, that we can listen through our ears. That is called as the audible zone. Now comes the acoustic sound, which is varying from even up to 20 kilohertz. So audible sound is zone, and then acoustic is this zone. So we can go up to 40 or 30 kilohertz, 40 kilohertz. Now when we are talking about, then different principles are there. When we are talking about the ultrasound center frequency measurement, so ultrasound center frequency is generally considered as the 40 kilohertz. 40 kilohertz plus minus 2 kilohertz or plus minus 1 kilohertz, different manufacturers are talking as a different, which is known as the ultrasound center frequency measurement. So that is considered as the 40 kilohertz plus minus 1 or plus minus 2. And then there is a last one, ultrasound wideband measurement zone, that some people are starting from, let's say, 10 or 20 kilohertz, and some people are talking from around 30 or 40 kilohertz, and it can go even up to 300 kilohertz. So ultrasound wideband is the zone where all these acoustic. So all these different types of things, these are the acoustic band, because they all are sound we want to measure. And for the sounds, we are having the different types of sensor. These sensors are acoustic, normal acoustic sensors. Then we can have the parabolic antenna and ultrasound center frequency probes. So as we can see into this thing, let me use the cursor. So this is the acoustic sensor, which is getting attached directly on the transformer body, or for that matter any other body with the magnetic things. The center white zone is actually the sensor, and other part is the housing of that sensor. So this is working on the ultrasound wideband generally. When we are talking about the center frequency zones, That sensor can be like this one as an example, or it could be something like ultrasound probes kind of a thing. These are the parabolic antennas, and this type of a instruments, this type of a ultrasound instrument that can be once again of two types: ultrasound with center frequency only, or ultrasound wideband. Both the things are available into the market. Now going to the next band, as we can see, we have added now the high frequency. So high frequency is starting obviously beyond the ultrasound, or it is the overlapping technology. So though we are talking ultrasound wideband can go up to 300 kilohertz, whereas HF signal or the high frequency signal can start from 100 kilohertz and it can go up to 20 or 30 megahertz. So if we are looking for the high frequency sensors, all those sensors will be available into this zone of bandwidth. In the high frequency sensor, we can have two types of sensors majorly: HFCT, which is also known as the RFCT, radio frequency sensor, radio frequency current transformer, or the high frequency current transformer. So HFCT and RFCT, or we can have the coupling capacitor. HFCT and RFCT is generally used for the cable application, and coupling capacitor is generally used for the generator and motor application. So these are the, in the right hand side we can see the coupling capacitors, and these are the various types of the RFCT and HFCTs. Depending upon the nature and connection possibility or the diameter of the cable, all these things put together, we have to decide which type of RFCT we should use. And when it comes to the coupling capacitors, it is majorly the voltage level of the motor or generator. Now, some of the people's used to write when they are you are going for the tendering, you are mentioning, I require 1 nanofarad or 1.5 nanofarad or 2 nanofarad. My question is that, do we really require that? Because the moment I am mentioning, I myself as a purchaser, I am mentioning the which type of what is the capacitance value required, because all the manufacturers of the different partial discharge are having different types of coupling capacitor. I should be concerned about my voltage. I should mention how much voltage is my motor, what is the voltage, because it is directly getting connected into the motor or the generator. So I should be mentioning only the voltage level. Let the manufacturer have their own design of the coupling capacitor. Design means value of the coupling capacitor. Because if one manufacturer is manufacturing at 1.1 microfarad, and if we are asking 1.2 microfarad, they will not prefer to make a different type of a thing. Either they will fool us, because these are the special type of a capacitors. Those are not available readily in the market. We require a lots of design, because we have to take care inside these coupling capacitors there should not be any PD. So people are not generally ready or to change the specification. So we should be concerned about the voltage level more majorly, not the other way, the value of the capacitance. Then comes the very high frequency zone, which is generally from the zone of 10 megahertz to 100 megahertz, where in the VHF signal zone we can talk about the TEV sensors, transient earth voltage. So where these transient TEV sensors are used generally at the time of PD, if some flashes is happening, some voltage is getting transferred from the live zone to the dead zone or the earth zone. So there, once there's, let's say, talk about the panel. So from the surface inside to the transformer panel body, there will be a spark or some discharge will be happening. So once that thing got discharged into the panel body, now panel body is earth, and that discharge or that charge will now try to transfer immediately to the towards the earth. So during that transfer, there will be some voltage, microvolts or millivolts we will be getting depending upon the how much discharge it is happening. There will be a transient earth voltage will be getting generated immediately after the partial discharge. So these sensors, these transient earth voltage sensors will capture those sort of a transient voltage which is flowing towards the earth, and those are working into the zone of 10 mega to 100 megahertz zone. Then come to the ultra high frequency band. In ultra high frequency, once again, there are the various band starting from 300 megahertz to 1.5. Some people are talking about 1 gigahertz or 1000 megahertz. Some people are talking about 1200. Some people are talking about 1500 mega. Some people are talking about even 2000 or more than that. Now, it depends upon the manufacturer how much capable they are. Number one, how much confident on the captured signal they are, and third thing is that how much there is there what we say is the processing capacity and the way how they are doing the processing of the signal. So based on that, they are selecting the ultra high frequency band. But generally, when we are talking about UHF band, 1500 is a widely accepted 1500 megahertz is the widely accepted band, and a lot of manufacturers are giving that. But at least 1000 is the minimum when we can talk about the ultra high frequency, because more than 1000 is we are getting generally up to 1500 we are getting maximum of the signal. So in between 800 or 500 and more to 1500, in that zone we are getting majority of the signals. In the UHF zone we can have different types of sensors. Once again, the like this antennas, as you can see in the left two. These are the different types of antenna. One is the directional antenna and another one is the non-directional antenna. And these two are the UHF sensors. These are two sensors for the GIS. The right one, this one is for the internal application. So this sensor will be installed internally into the GIS. So this can be installed only at the time of manufacturing, or it can be installed later on also, but for that one we require the entire GIS to be dismantled and has to be fixed from inside. Whereas the left hand one, this one is that we can have this one as a temporary solution or external UHF sensor, so which we can attach to the GIS body, the junctions, and do the measurements. Now coming to the different sensor applications or where we can use which sensor. For the power transformer, practically we can use any type of a sensor. When it is acoustic, it will be used in the body. TEV, once again, into the body of the transformer. HFCT will be used in the earthing path of the transformer. UHF sensors like the head sensors or the drain valve sensors will be used. Similarly, for the instrument transformers, in case of generators and motors, acoustic is not that much useful, but theoretically it can be used, because generator and motor generally at the time of running they will be generating a lot of sound. So acoustic is not that much, rather very rarely used in case of a generator or motor. Majorly used over here is the coupling capacitor. However, we can use the TEV for the metal clad or metal enclosed generator and motor application, or in the body you can put the TEV sensors also. But the most effective thing is the HFCT, or coupling capacitor, or HFCT can also be used into the earthing path of the generator or motor. But UHF is not generally used for the motor and generators. Now, when it comes to the switchgear panel, the most effective thing is the TEV, and other sensors, like in the once again into the cable earthing path we can use the HFCT, or into the switchgear body we can use the acoustic. For cable application, the most preferred thing is the HFCT, which will be using generally of the cables. However, we GIS, as the GIS is a highly insulated thing, we cannot use the TEV, because TEV is not going to give us any result in case of a GIS. However, we can get the acoustic, but not that much effective. The most effective thing for the GIS is the UHF sensors, followed by the acoustic and HFCT sensors. So from this discussion, we can give this suggestion that the best possible sensor configurations are like acoustic, most suitable for transformer application; HFCT is most suitable for cable; coupling capacitor, most suitable for generators and motors; TEV, most suitable for the switchgear panel; and ultra high frequency sensors, most suitable for GIS. So this is as a thumb rule we can keep as a reference. Now, once again, the next poll I'll be asking you to participate, that do you have any PD measurement kit in your organization? Because now you can understand a bit more into the PD things. So do you have the kit in your organization? You are already having, or you do not have, or you are planning to purchase into the near future. That near future could be 1 year, 2 year, or 6 months, whatever it may be the time frame. I request you to put your answers on the poll. Now, coming to the various analysis tools. So here, let us start with the PRPD, which is the very basic and must-have kind of a thing. PRPD full form is the phase resolved partial discharge. So the partial discharge, when it is happening, the signals I am getting, fine. Any signal coming into that zone means I have got the PD. No, it is not like that. There are some PD pattern. So to understand, like the first thumb rule of partial discharge is that okay, PD will happen only into the rising edge of the voltage. PD will not happen into the falling edge. That means when we are talking about this graph or the 50 hertz signal as shown in the blue, in this one, whatever is happening on the first 0 to 90 degree zone, so in this zone we can get the PD. This is the zone. Whatever is happening, it can be a PD. In the second zone, as marked into the red, I am marking into the red, in 90 to 180, whatever is happening, this is the falling edge. From peak to zero it is coming. So here PD will not happen. Similarly, 270 to 360, this zone, whatever the signals it is coming, here it can be neglected because PD will not happen into that zone. So my interested zone or target zone is from 0 to 90 and 180 to 270. this is the zone where I am getting the signal. Those could be the probable signal. So first and must have things is this partial discharge, PRPD, phase result. So for that one, some people are giving the directly as a 50 hertz as the input, give the key in as the 50 hertz. So there are two ways to understand this thing. 50 hertz is the ideal frequency, but if it is 49.8 is your system frequency right now at this moment, and that time you are getting the PD, several very high peak of partial discharge signal or some signal you have got, and that is with respect to 49.8, it is beyond that 90 degree or into the zone of 90 to 180, which is not a PD. But as I have given as a 50 hertz, it could be shown as a PD. So we should actually do the phase sequencing, or the phase resolve partial discharge has to be done on the real time phasing. Phase comparison should be available into the kit. Then comes the phase resolve pulse sequence. So what are the sequence it is coming? It can be viewed on the 3D. So in the 3D pattern, when we are putting the partial phase or the frequency phase, then we can understand at which how the pulse sequence is coming. Immediately one by one, or it is a series of pulses, and what type of a pulses it is coming, and at which zone to 180 or 180 to 270 or 270 to 360, which zone it is coming. Based on that, we can negate that yes, these are the PDs, those are not the PD. As shown into this picture, on the right hand side, we can see the very high red color signal, but it is happening where almost into the zone of nearer to the 350 or 360 degree. So that means it cannot be the PD. It must be some other signal or some other disturbance which has got caught. So only that pulse sequence we can understand, and here we can understand a series of signals has been captured by the sensors, because there are so many samples has been taken up by at that location. Then if the kit is going to give you which type of a PD, the software is going to give you the which type of a PD, because understanding as a user of the PD kit, if the kit is giving the PD signals, okay, fine, I got whether it is PD or not, but how many people could be master in PD? That is questionable. And I have understood, okay, it is might be a PD, but whether it is a PD, whether it is matching with the reference signal 10,000 or 20,000 or 1 lakh of signal reference signals whichever been published by IEEE or SIGRE body, whether it is matching, my signal is matching with any of them, it is not possible for me as a, because I have to, my basic job as an electrical engineer or as a maintenance engineer to maintain, not to understand the entire PD, or I have to be a very much expert into the PD to understand that which type of a PD it is. So if the software is having that intelligence to compare the obtained result with the reference signals published by the established bodies, then it is easier for me. My job is easier. So if I should look forward for a system or the product which will identify which type of a PD it is, like in this case, this software is giving the floating potential, where we have got it in channel 1, phase A, danger level, how much it is middle, how much power it is getting discharged, what is the amplitude of that PD or that peak voltage I have got, and what is the accuracy. Accuracy means how much percentage of my obtained signal is matching with those tens thousands of reference signal, how much it is matching, because getting a manual match because 10,000 different types of a standard signal. From that one signal I have to match. So it is very difficult task for a person to manually match. But what an artificial intelligence or a intelligent software can do is this matching pattern, because a computer edit, I have to get the matching accuracy, how much it is matching with a standard or reference signal. So which type of a PD with this sort of analysis is a desired thing. Noise cancellation has to be or must be available into the system. Otherwise, because anytime we are going for the partial discharge testing, we will be getting a lots and lots of noise. So instrument should be able to identify whether it is an external noise or it is a real partial discharge, as the instrument in this case has identified as a noise or external signal. Then comes the PD mapping. Here lies the expertise, because by using the kit 10 times, 20 times, different signals, I will become or I will be master towards the subject. One day, next day, I will be knowing something more in that fashion. So then I will be able to understand what the exact things is going on, where it is going on, or how the analysis is getting done. So this sort of a PD mapping feature or the 3D mapping feature is really helpful for those sort of advanced analysis, in which plane it is happening, where is the exact location of the PD it is happening in the three-dimensional way. If I plot the transformer, so this is the zone. In the x-axis it is in this zone, y-axis this much, z-axis this much, so this could be the probable zone. So that sort of a 3D mapping feature should be available to identify which is the exact location of the PD is happening. Then comes the PD cloud. So in a three-dimensional object, how the distribution of that partial discharge signal is happening, because when I am doing the sensor analysis, multi-sensor means simultaneously more than one sensor I am capturing the data. So the moment there is a partial discharge, the same signal will be picked up by all the sensors or majority of the sensors. So at that time I will be distributing, I can generate a PD cloud, something like with the software iteration I can create a PD map. Okay, in this zone the PD might have happened. So from that one I will be once again able to understand, yes, this is the zone, this is the probable problematic zone. So this 3D mapping, PD cloud, all these applications are for the what you can say is for the advanced level of users, but you should be looking forward for these features. Today on day one, none of the people will be able to use that, but the moment you are purchasing the kit, it is that kit you are going to use at least for next 10 years, if not more. 7 to 10 years at least you will be using. So down the line, 7 years or 10 years, you will be going to be an expert. So those time you will be able to use that feature. But day one itself, if those features are not available, so in future also you will not be able to reap the benefit. And time of flight or time of travel, this feature is available and very useful when it comes to a location finding, PD location, where it is. Because last point is that okay, the moment you got the answer, okay, yes, PD is happening, but where it is happening, that is the thing. Until and unless where it is happening, I don't know anything. So I should know where it is happening. So multi-channel kits are equipped generally with this time of flight or time of travel concept, because the same PD signal will be picked up by the different sensors, and different sensors are located at different location or different distance from the, in a simple word I can explaining this, the distance from the PD location to the different sensors are different, or one might be at a let's say 0.5 meter distance, another might be of 2 meter, another might be of 5 meter distance or 10 meter distance, in that fashion. So the same signal will be picked up by the all the sensors in different times, and then by doing the analysis of the travel time of the PD sensors, we can extrapolate, yes, this is the probable region, or we can pinpoint this is the zone from where it is coming for the GIS, for the cable, for the transformers. This time of flight or time of travel is very, very useful for the GIS or for the cable. Even for the transformer also, it is useful. So now once again, there might not be the kits available in your organization, the partial discharge kits. But are you interested to get the PD testing of your assets? Do you know that Scope is also offering this PD testing as a service? So if you are interested to get the PD testing done, you can contact us and you can put your expression that by clicking on yes. If you are having your kit or you are not interested to have that, no. Or if you cannot comment right now, you can put maybe. Now let us come to the zone of how the product selection should be done for the PD kit for your application. So as I have told you earlier, detection, identification, localization, and training. These are the 4 stages of the PD identification. And also we have discussed about this chart, which object is best tested by which method of kit. So you have to identify which type of testing I want. And also we have talked about the frequency band. So once that thing is we are crystallizing, then we will be able to select the proper product, or I'll be able to drop the proper specification what I require, that way or what is the best suitable kit for me. So all these products now we are going to talk about, we will be trying to map all the products with respect to this thing, or when we will be going through the product details, you can map it on your own with the product selection zone. So 3i is the very basic PD handle detector. We used to say it, we can say it is something like a multimeter, a must-have kind of a thing for an electrical engineer. So similarly, if you want to detect the PD existence, this is a very good and quick product. It is having 2 channels. Any one channel you can use at a time. Either it can work on the acoustic channel or it can work on the HF or the TEV sensor, TEV channel. So they are having the inbuilt sensors also, or you can attach the external sensors as shown over the picture over here. You can add the parabolic antenna or the acoustic probe or the RFCT or the TEV externally, or directly without attaching any of these sensors, directly you can touch the product onto the surface of your transformer or panel through, and as you can see over here, it is mentioned as the sensor. I am showing the location. In this zone, there are the inbuilt sensors. This black dot is the acoustic sensor, and this remaining part of the surface plate is working as the TEV sensor. So both the things are clubbed or sandwiched into the same thing. So you can hold this instrument directly on the panel or some transformer body to get whether the acoustic or the TEV is happening or not. Or else you can attach any of these external sensors as shown over here. Any of these sensors can be attached externally for increasing the measuring range or the usability of the product. It is very useful for the switch gear, joints, cables. So it is all in one kind of a thing. Or you can say whatever the measurements possible with the help of acoustic and TEV, this kit can be used. So this is working on the two principles. It is working on the VHF as well as ultrasound center frequency. So this acoustic channel is working on the ultrasound center frequency zone, 40 kilohertz plus minus 2. And when it comes to the TEV sensor, it is working into the zone of up to 100 kilohertz. Sorry, 100 megahertz. So here we can use the detection of the existence of the PD. How much is the PD, that we can see into the LCD screen. What is the count, how much dB, or what is the severity of the things, but no graphical analysis as shown in this PRPD and other things are not available. As I have told, this is a very basic kit, and with the help of this kit, if you to keep on the data logging, you can get the trend of the product also, the trend of the partial usage also. Then comes the another product in the acoustic, working on the acoustic principle only, but ultrasound camera. So it is once again the better or advancement of the ultrasound probes, whichever we used to use for a longer duration. Now those ultrasound probes, multiple probes are attached to a single product along with a visual camera, and software integration will give you the images as shown over here, that this is the substation overall, and in this one near to this city there is some problem, because here it has been highlighted with the color, and what type of a problem, that also is getting displayed on the top of this screen. Okay, what type of a problem, and here that the type of discharge will get displayed over here, so you can quickly understand where the problem is and what type of a problem it is. Also, this ultrasound camera not only can be used for the partial discharge or corona discharge, it can be used even for the other sort of leakages, any type of a gas leakage or high pressure water leakage. Those are anything, whichever, wherever there could be a leakage is generating some sound, it will be able to capture that one. So we can get the advanced analytics by way of the Wi-Fi connection, AI powered software, which is a cloud-based software, and automatic report generation can be done. You can store the videos, or the still photography also can be done. So still pictures or the videos can be stored as per our requirement. Advanced signal processing with AI is combined automatically to give what type of a discharge it is happening, whether it is a corona or it is a surface tracking or treeing, what type of a PD it is happening, different signals, as you can see over here. Based on that, you will be able to understand. So AI software, cloud-based AI engine will give you what type of a PD it is, whether it is a corona or between two surfaces, or it is the surface tracking, what kind of a PD it is, it will be shown. So typically ultrasound solutions, generally it is required for the highly capable persons. You require an expertise to identify the location, because you have to do it, understand from the graphs or from the count. You have to understand where the count is coming maximum, where could be the probable zone, that sort of a thing. Whereas with the help of these cameras, we can directly see where the problem is. So it is much more accurate and much more fast or quick analysis tool, we can say. So this instrument can give you the detection, identification, which type of PD it is happening, localization, as you can see it where it is happening, and Always, if you keep on doing the things, you can use it for the trending of the partial discharge signals. Then coming to the DIMLOG 4, which is called as a handheld surveyor kind of a product. It is a truly all-in-one product. If you are looking for a single partial discharge kit which can cover all the assets of your substation, so that kind of a thing, we can do it with this sort of a product, with this product, because this product is having 3 channels as shown over here. However, these 3 channels are working on 3 different frequency band. One is working on the acoustic, second one is working on the HF, and third one is on the ultra high frequency. So as we can talk about the, now if we refer to our product selection guide, that chart, that acoustic, yes, we can cover the, with the help of acoustic transformer application. With the HF, we can use for the panel, cable, and even the motors and generators, those zones. And with the help of UHF, we can use it for, once again, for transformer or for the GIS application. So it can be used as a overall all-in-one instrument. But here the limitation is only single channel measurement. However, it is a quick, lightweight and compact. All the other features like PRPD, 3D mapping, all these features are available into this kit. You can save the memory into the inbuilt and save the results into the inbuilt memory, or it can also be used for a downloading into the desktop PC. You can share the data, you can automatically generate the report. All the other features are available. So this product, as you can see, it can be used for the power transformer, as I have already told. HFCT and coupling HFCT are supplied. If you require the coupling capacitor, that can also be supplied as an optional, or if you are having your existing coupling capacitor, those can be also be integrated or used for the measurement with this kit. TV sensors can be attached to the HF channel, and then we can also use the UHF signal for the GIS application. So once again, here we can use it for the detection, identification. Localization, I have used a not that much dark color, because here localization can be done, but it requires a personal expertise, because with the help of the various angular measurement and various location measurement with a single kit, you can do the localization, but it is a person dependent and you require expertise to identify the exact location of the thing. Trending, yes, it can be done with the manual trending. AR700 is the kit. Specifically, now we are going for the multi-channel kit. So AR700 is, the moment we are talking about the multi-channel, generally all the manufacturers will give you the multi-channel, means it is the same kind of a channel but number of channels more, because we are now talking about the higher level of measurement, where here this is for the 4 channels acoustic only. So it is dedicated for the majorly most useful for the transformer application, and it is having an inbuilt, even inside the instrument itself, you can get this type of a 3D diagram of the transformer. You change the dimension of the X, Y, and Z pole. Accordingly, you will be able to map the 3D mapping of the transformer, and you mark the location of the sensor on the X and X, Y, Z plane to get the exact location of the partial discharge inside the transformer. It will automatically give you the location study automatically. So here acoustic means it is, as you can understand, it is specifically or more suitable for the transformer application. However, if you are interested to use the acoustic sensors for the GIS application or the panel application, we can use this kit also for those sort of applications. Then comes the multi-channel HF and UHF kit. So here we, in this left hand side kit, this one, this is having 3 channels, and the right one, this one is having the 6 channel. The remaining function and specification of the products are same, only the number of channels is different. So it can be used directly 3 channels at a time. So HF and UHF, that means these kits can be, is more suitable for the generators, motors, cables, and GIS. These are the things specifically more suitable, because HF and UHF, both these two frequency bands are available into these kits. And as per the application of yours, we can have the different types of sensor. Like in this one, extreme right hand side, we can see the coupling capacitors are available. So these coupling capacitors are used for the generator and motor application. These are the sensors for the GIS application, UHF external GIS sensors. And these are the different types of RFCT arrangement. So we can use it for the cable application. Now, coming to the product mapping, this product once again can be used wherever this HFCT and or the TV are used. This is the zone, sorry, this is the zone. When we are talking about HF, we are talking about HF as well as VHF, and UHF means it is the dedicated UHF. So both the two things are available into this one. So this kit can be used for all the applications as mentioned, shown over here, and it can be used for the identification as well as localization, because it is a multi-channel. Time of flight or time of travel feature, all these things are already available inside the kit. So automatic analysis are available. So we would request you to contact us if you are interested in the demonstration of any of our these PD products. These are the portable PD products which are, we are having the thing. We are giving the testing services, as well as if you are want to purchase or interested to see the demonstration how the kits are working, then you can contact us. You can express your things into the poll, that if you are interested, or if you are not right now interested, you can keep our contact details for your future references. So in short, in a nutshell, this is the total product offering from Scope. As the subject has suggested today, we have discussed only about the portable solutions available with us. That means the left hand sides we have considered up to this zone. However, we are having the 24/7 monitoring systems also in with us available. That we will discuss some other day. Principle of operation is same, but those are the 24/7. So continuous monitoring, the configuration and other things are different. However, the basic operation principle is same. So it is a small snapshot of what are the products and which can be used for which application. So it is a quick reference guide kind of a thing. You can refer for any of our future queries or demonstration need, which product you require the demonstration, that purpose. So we are almost at the fag end of our session, of our discussion. So, and if you are having any questions, you can type the same into the chat box, or you can contact us with any of these email IDs for future.